What's up, guys? So it's James Carino again, and I'm back with another video, another programming Java coding challenge. And it's only been 23 hours since the last post. It was about the transpose two strings via adjacent swaps of the first string. Definitely check that out. It's only been 23 hours, and there's 44 views. I am grateful for each person who took the time to watch the video. I'm grateful for each 44 of you as of right now, and I'm grateful for the next viewers and subscribers. So today we have a new challenge. This challenge is a little bit of a twist from the lead code challenge. The lead code is happy numbers. You can check that out. It's a happy number is defined as a process of define the following process to calculate the happy number. This is how you calculate it. Given 19, 19 square it, 82, 82 square it, 68. So pretty much you're getting the sum of the squares, and if it hits 1, it's a happy number. In this case, it does not hit 1, so it's false. Um, so the coding challenge today is happy prime numbers, base 10 numbers that are referred to as happy numbers, but the twist is we're going to get prime numbers as well. So it's a happy prime number, the intersection of both those numbers. And we're going to be printing it to the console via the user input. So let's go ahead and start. Um, so these are this is the list of the first few happy prime numbers. 7, 13, 19, 23, 31. So we're going to refer to this later on. How to find a happy prime number, pretty much as explained, you're getting the sum of the squares. So 23, the square of 2, and then square of 3, and then add it up, and then you're pretty much splitting it and then getting the sum of the squares. So what I did earlier was I made a flowchart. As I said, my passion is software engineering. I love the whole process of creating the whole program from the start to finish. And this is just a basic flowchart showing how the process, what we would do today is, so to do the happy primes, right? So we start here, we enter here, start is the input of the user greater or equal to 1. No, input should be an integer greater or equal to 1. If they input a string, we're gonna put an input exception, mismatch exception, turn false, prompt user for input again, start. And then is the input greater or equal to 1? Say yes. We call the function is happy prime, passing the input of number of digits needed. So the number of digits needed is the input, aka the length of the array. Create a hash set, happy prime set with maximum length as input. So we're gonna create a hash set, and the reason for this hash set is because hash sets only take in unique numbers. So that's the whole point of creating the hash set. But the hash set actually is going to go inside this happy prime number method. That's what we're going to be doing. Is the maximum length reach? No. Is it no happy number? Yes. Is it a prime number? Yes. We're going to add it to the set, and then until the maximum length is reached. So if it's a happy number, yes, it gets to prime, and it's not a prime number, it goes back, it loops back again, it calculates everything, and once the maximum length is reached, we return true and we print the set to the console. So let's go ahead and open your development environment. Okay, so what we're going to be doing today is a little bit different. We're going to be doing an object-oriented approach. So what I want to do is I'm going to do 3 classes. One will be the main class. The other would be for the prime class, where we're going to be calculating the prime numbers. And let's make another class for happy class. Same happy class, where we're going to calculate the happy numbers. Since we're doing a object-oriented approach, basically we need to do a default constructor here. So we do a public happy class, and this is a default constructor. Same thing for a prime class. I'm going to make a default constructor since we're doing a object-oriented approach. All right. And as we mentioned in the diagram, we're going to check if it's a happy number and if it's a prime number. So basically, these two classes will have Boolean methods, or we're going to be checking if it's a prime number and if we're going to check if it's a happy number. So let's first start with the prime class, right? So we can make a public static, let's make a Boolean is prime, where we're going to take in the number, and we can do a throws legal argument exception. The whole point of the illegal argument exception is if n is less than 0. If n is less than 0, then is prime is false. So if n is less than 0, can't have a negative prime number, right? So, sorry. I'm trying to rush this that way. Not really trying to rush it, but I'm trying to rush like the typing that way the whole video uploads on YouTube later on. So if n is less than 0, is prime is equal to false. Oh, we have to make a Boolean is prime is equal to true. Set is prime to true, set is prime is false here. All right. And we say throw the exception the number is less than 0. It's actually let's do the string format. That. All right. Next, else if n is equal to 0 or n is equal to 1, is prime is false also, because 0 is not a prime number and 1 is not a prime number. All right, next, let's make a for loop. We're using 2 because we're gonna be using that to start. If it's divisible by 2, then obviously it's not a prime number. So this is the check that we're gonna be doing. Less than or equal to n divided by 2 plus I. Then let's make a temporary variable where we're gonna use n modulo of the I. So we're gonna do I here, and then we're gonna put an if statement. If temp is equal to 0, false, and turn is prime. You don't really have to do that because it's already this is not you don't have to do this. Return false. Can you say return false? Prime class turn a value from a method. Let's see if equals to 0 is prime. Let's see if we can fix this false. And then it's prime. Wonder why it's giving us an error over here. Make prime class return boolean. Did we not? Did we say prime class return boolean? Oh no. Oh no. Yep, that bracket right there. It makes a big difference. Well, you technically can return false, or you can technically return is prime. Same thing. Let's see. All right, we have an additional bracket. That's what it is. Next. Okay, boom, boom. Return is prime, which is true. So if it passed all these tests that we did right here, it is prime, right? So everything here would be prime. Let's check. Int x is equal to, let's choose 4. 4 is not a prime number, obviously. What we could do is we can make an object. We can make a boolean. Temp boolean. Make temp boolean here, right? And then let's say boolean is equal. Temp is equal to is prime class dot is prime. We're accessing the method is prime from the prime class, and we're gonna input x, and the whole point of this is to check if it is indeed prime. Is 4 prime? I'm gonna be checking it. False. False. Is 5 prime? Okay, so we know that the is prime works. That's important. Is prime works. Let's do another one. Let's do a 9. False. Perfect. Because 9 is divisible by 3 and not just itself and 1. So that's pretty much what prime is a number that's divisible by itself and 1 only. Okay, next would be the happy class. The happy class where we're going to be doing the sum of squares. Pretty much we're going to be doing the sum of squares, and we're going to be doing a boolean again. Let's not make the same mistake here. Keep that. Let's do an import, because as I said, we're going to be doing a hash set. The point of the hash set is because we want to check if the characters or the values inside the hold on, right there, sorry. We want to check if the values inside the set is unique, and hash sets only allow unique characters or unique values inside their sets. So that's the whole point of using it. We're going to be using it as a boolean to check if it's true or not. All right, so public static boolean is happy. All right, can do with throws, same thing as the other one. Illegal argument exception. Let's figure that out later. That's easy. Let's do a boolean and then is happy, and let's set that to true. All right, same thing as the prime class. We did a boolean is prime, and this one is happy. Now, as I said, we're going to do a hash set, and let's say scene numbers or happy numbers. Let's do happy numbers. All right, let's do happy numbers equals new hash set. All right, so now we made the hash set over here. We made the Boolean over here to check. Now let's make the sum, because as we said, we're gonna get each digit of the number given, and we're gonna do a square of the sum of digits. Okay, so int sum. Let's set that to 0. All right. Now let's do a do while. Do while sum is not equal. Oh, sum is not equal to 1. So we're gonna keep doing it while sum is not equal to 1, because if it is equal to 1, then it's happy, right? Sum equal to 1, then we're gonna return is happy. So whatever we're going to be doing over here in this do while loop, we're going to be doing the sum of squares, and if the sum is equal to 1, if the sum is equal to 1, then we're going to return true. While it's not equal to 1, we're just going to keep doing the do while. Obviously, it's going to be it might be an infinite loop, but we're going to fix that. So as I said, we're using the hash sets to check if it's unique, right? So return false. Okay, if the number that you put in is not unique, we return false. So we're going to break out of this do while loop, and it's obviously not a happy number. It's an unhappy number. Now for sum equals 0, start at 0, n greater than 0, okay, and this is pretty much saying n divided by 10. N divided by 10. So sum plus equals math dot pow n modulo Calutherm cares. N modulo 10. That's the first, and we're gonna do a 2 right here. All right, so let me explain it right after. Okay, hold on. Right after I do this, I'll explain everything to you guys. That way you guys can better understand. So pretty much, okay, to pretty much retract, if the number is not unique, we're going to return false. If it is unique, then we continue, right? We continue until it's not unique, and we continue here. It's a happy number. So pretty much we enter non-zero positive number, right, which is n, and assign it to the value of n. We keep it as n over here. We set sum equal to 0. This is redundant actually. Let me just that here, sum is equal to 0. Okay, calculate the square of the remainder value, right? And we do so we set sum equal to 0, n is greater than 0, n divided by 10, right? N is equal to n divided by 10. Sum plus equals, this is pretty much saying sum is equal to sum plus math power n modulo 10, right? We're calculating the remainder, right, by dividing it n modulo 10, and then we're going to square the remainder to 2, right? And we're going to set whatever is in this sum to n. All right, that's pretty much what we're doing there. This is If you have any more questions, this is pretty much the standard. There are other ways to do the sum of squares, but this is pretty much how I did my sum of squares. So yeah, that's pretty much how I did my sum of squares. All right. If you guys want to check if this works, always true. Okay. False, false, true, true, true. And let's put this. Let's make it neater. Right there. Okay. Now, let's check. Let's check first if it's a happy number. And going back, what is a happy number? A happy number is a 1, 7, 10, and 13. Let's try 13. Boolean x is equal to true. See, x is equal to prime class. Oh, happy class dot is happy. Let's put in 13. Let's put in y, which we're putting in 13, and system dot out dot print x. So this should print out true. Okay, and not a happy number is, let's say, 22, right? 22 is not a happy number, so let's check that. 22. False. Okay, so during the test that we did right here, we're pretty much, it's looking like everything is on the right track in the case of happy numbers and prime numbers. 23 is a happy number. Yes, it is. Okay, so we did the happy number and the happy and the prime numbers correctly. Now, actually, we can take this off right here first. I want to focus more on the fact that we're doing happy primes. Now let's do the main method. All right. So in the main method, what I'm planning to do is we're gonna put in two booleans, right? Temp prime. That's to check if it's true that it's prime, and then another one, temp happy. And if it's temp, and if this is both true, then it's a happy prime number, and we're gonna add it to the array that we're gonna create. All right, so I'm gonna make another one is successful, false. All right, I'll explain that later on. Let's do a scanner. Keyboard, the standard that I do every single time. Scanner system in what okay, system dot in. So we're gonna grab the input from the user. All right, int target index is equal to 0. All right, and let's do a try. Let's do a try catch. We'll be doing a try catch because, as we said, we're gonna be making sure that the input is greater than or equal to 1. I mean, it is greater than or equal to 1, right? And it's not a string. So input greater than or equal to 1, yes. Go here, go here, go here. If it's not, then we go here. All right, so we can do a catch, and we can do an input mismatch exception. All right, we can do an input mismatch exception. Let's call it variable 1, right? And you can say system that out that print invalid input. We cannot put in a string. Same thing, we'll do the same thing over here, but then rather than input mismatch, we can do negative array size exception. And we can do it on variable 2. Please enter a number, positive number, greater than 0. Alright, because we want it actually greater or equal to 1, and if it's a negative number, we can't really, there's no array that would have negative number of values in it. Alright, so next let's do a system dot out dot print line how many happy primes do you want, right? Number is equal to keyboard dot next integer, and we're gonna put whatever they want right here in number. And let's do a for I equals 0, right? And we mentioned target index less than happy. All right, happy. Oh, before I forget, the most important, where are we storing it? We're storing it in an array of happy prime numbers, right? That's where we're putting that's where we're storing the happy prime numbers. And we're gonna put in the number, right? That's the maximum, and that's the name of the array that we're putting it in. So we're gonna do happy prime numbers dot length, and then plus I. Oh, I. All right, now we're gonna say, okay, the temp happy, right? And we're gonna set that how we did it a while ago. So we're gonna go to prime class, right? Prime class dot, is it prime? Is I prime, right? And the same thing is, temp prime and temp happy. And we're gonna say, okay, is I happy? And then it's gonna store the values here. And then what we're gonna say is if, right? If it's both true, we're gonna put that number in the array. Target index equal to I. We're gonna put that number that we're iterating to the target index, right? And the target index we said was 0. The whole point of this is because we want it less than the maximum number, right? Because if we keep going and we just set I less than the maximum number, we're not gonna get the amount back, because I is gonna keep iterating and it's gonna hit the maximum number. If target index was continuously 0, right? Even if 0 and 1 was already iterating, if 0 is 1 is already iterating, then this is not gonna be iterating up. Target index not gonna be iterating up, and this is not gonna be true. That way we can continue this for loop. All right, so we set whatever is in I to the array, and we we iterate up the target index. We do a plus plus on it, and we do a system dot out dot print line on I. That way we see it, right? And we're gonna be doing is we can do a system dot out dot print line, right? Your happy prime numbers are. So if you know me, if you've been watching my videos, I just really want it to be like this. I want it to be neat, and it really helps me with catching errors. So that's just my thing. Every programmer has his thing, and this is my thing. All right, and I guess that's it. I never used is successful. Let's take that off. Looking at everything. Let's try it out. How many primes do you want? 6. 1, 2, 3, 4, 5, 6. 7, 13, 19, 23, 31, 79. Let's check. We gotta check. Let's move this right here. Here. The first few primes are 7, 13, 19, 23, 31, 79. Let's go higher. Prime numbers do you want? Let's do 10. Alright. 7, 13, 19, 23, 31, 79, 97, 103, 109, 139. Perfect. And we got it. Want to test the code? Let's put in a string. Let's put in G. We cannot put in a string. Let's do a negative for the maximum. Please enter a positive number greater than 0. And back at it there. 1, 2, 3, 4, 5, 6. Perfect. So this is pretty much how we did the happy prime numbers. Congratulations, guys. We did it again. We did an object-oriented approach. We have software engineering, flowchart. Doing these flowcharts, it's not going to be perfect, but the whole point of it is that we're able to easily see how everything flows, quote unquote, how everything flows in the system. Doing this would help us code faster, and because taking your time, making these diagrams. There's different kinds of diagrams, use case scenarios, that helps you with each use case on how the user enters stuff. You got the class diagrams. You got sequence diagrams, you got state machine diagrams. I just did a simple flowchart just to show you guys how this project works, how this whole project works from start to the finish right here. So that's how we're doing it, and we did the happy prime numbers, guys. We did something that's above the leak code. Happy numbers. You guys should be proud of yourselves. So once again, this is James Carino, and we did another programming challenge. Make sure to subscribe. Check the other videos. We'll be uploading this very soon. And all right, see you guys. Bye-bye.